Okay, sorry about all the coughing in the last one. I've got some water, so hopefully we can finish this up. Okay, so with integration comes some rules. Okay, so we're going to go over a couple ones that are pretty beneficial to us. The first one being what we call the zero rule. I don't know if that's really what it's called, but if we have an integral where this value on bottom is the same as the value on top, we wind up getting a zero error area. So if we think about a graph, okay, let's say that's our function, and we look at A. Okay, so we cut it off at A. Well, there's nowhere else to move, so really what we're doing is we're finding the area of a line, which by definition doesn't really have area. So if we're not moving, we can't have a region to find the area of, therefore it's zero. So biggest thing you need to know is that if our top limit and our bottom limit are exactly the same, we're going to get a zero area. Okay, the second one has to do with direction. If we get an integral where our higher numbers on bottom and our lower numbers on top, that means we're reading our graph in the wrong direction. Okay, that means we're reading this way instead of the proper way from left to right. And we can change that direction, just like in physics, you change direction by changing sign. As simple as that. So we always want our lower value on bottom and our higher value on top. Anytime that doesn't happen, we can change the direction, which can change the sign. Okay. The next one is that additive interval property, and what that says is, we've actually already been doing this. We can actually split up, let's say we have a graph that looks like this, and if I want to go from here to here, I can choose to split it up in the middle and calculate from A to C and then C to B. And we did that in our previous examples. The biggest thing you want to keep in mind is that wherever this one leaves off, the next one picks up. Okay. Some other properties we have, I showed you guys in the last one. Anytime you're dealing with a coefficient, we can move it outside of our process and evaluate it last. And really what that coefficient is doing is just dilating our figure to be bigger or smaller. So it doesn't change the area, it just dilates the area. Okay, and then of course the product and sum one, not product and sum and difference one, saying that we can do them individual. And again, that's something we're already doing naturally in our problems. So what that means for us is we can actually, if we don't know how to do this graph right here by hand, and we don't really know to do that because it's curved, therefore some of our geometric formulas wouldn't work. But if we know each individual piece, we can actually break it up into each term and evaluate it differently, or evaluate it by piece. So for example, I know from previously that we can split it up. One of my rules says I can split up term by term as long as the top limit and the bottom limit are exactly the same for each one of these terms. And I can even do one thing more by taking out that 3. Because it's a coefficient, even that 2, and because I know the integral from 1 to 2 of x squared is 7/3 plus 3 coefficient, the integral of just x is 3/2, that 2 being a coefficient, and the integral of just dx is 1. And then I can just simply calculate it piece by piece. Okay, I'm going to put that over 1. We're going to get a common denominator of 6. So 14 over 6 gets us there, plus 27 over 6 gets us there, and 12 over 6 is that one. And then of course just adding, we get what, 26 plus 27, which is 53. over 6, and that's not really simplifiable. So simplifiable, I don't know if that's a word, but I'm going to use it. Okay, so there's our answer. Same thing goes with this one. If we know pieces, we can use those rules above to kind of break it down. So I know the integral from 0 to 3 of f of x is 7 from here. I know from 3 to 5 of f of x dx is negative 4. So I could take this one and break it down from 0 to 3 plus from 3 to 5. That's that rule number 3 that says we can do it as long as where we stop and where we start match. Okay, and then of course, since I know 0 to 3, that's 7 plus a negative 4 for that other spot, so the integral is of course 3. Okay. Now the second one, if we look at our limits, that 5 is greater than 3, so the first thing I'd want to do is, in fact, change the direction, and we change direction by changing sign. Okay, and now that negative is part of a coefficient of 1, and we know from 3 to 5 is negative 4, therefore we get a positive 4 as the end result. So as we're going through some problems, you're going to see that these rules kind of come into play and kind of help us out throughout our process. So I'm going to stop the video there, and we're going to go over the rest of the problems tomorrow in class. So if you have any questions over the last video and this video, please write them down so that you're ready to ask them tomorrow when we start class.